Today is day 2 of finding area between two curves. And the step up in challenge level is that if the curves intersect at more than one point, you have to check each region to see which curve is above the other. So here's an example here of where one function is on top, but then it switches and becomes the bottom function. And this is going to be our first example. We're going to find the area between sine and cosine with the bounds x equals 0 and x equals 5 pi over 4. Here's our Desmos graph. I've got these entered in. I entered in that vertical bound as well. So we've got the y-axis as one bound, which is right here at the edge of the screen, and then the blue vertical line is the other bound. You don't have to put those in, but it is a nice visual. We can see that the sine and the cosine curve do intersect at that point. We can also see that they intersect over here, and the curves switch for which one is on top in each section. By the way, I also zoomed in. There's this wrench here that you can use to change the settings. So I zoomed in to between 0 and 3 pi over 2 on the x-axis and -2 to 2 on the y-axis, so I could really narrow in on the graphs for the region I'm looking for. Once again, pause your video, get the sketch of the graph down, and then we'll find the area together. Setting up our first integral, our area is going from 0 to pi over 4. That is where the graphs intersected the first time, and you all remember that from your unit circle trig. The function that's on top at first is our cosine function. Remember, cosine is the function that starts at 1. Sine is the function that starts at 0. So that'll give us the area of that first section right here between the two curves. And then we will add on the area of that second section. This one's going from pi over 4 to 5 pi over 4. I apologize, the stylus isn't entirely writing where I want it to. And that's where the function switched. Sine became the function on top, and cosine became the function on the bottom. Integrating each of these. The integral of cosine is positive sine because the derivative of sine is positive cosine. The integral of negative sine is positive cosine. So that will be from 0 to pi over 4 plus the derivative of sine is negative cosine. The derivative of negative cosine is negative sine. Careful with those negative signs. It is super tricky to work backwards and forwards with derivatives and integrals for sine and cosine because the signs, SIGN, positive negative signs, are opposite for each of them. And this interval goes from pi over 4 to 5 pi over 4. All right, we are going to use our trig knowledge to simplify these, and the pi over 4s aren't bad. That's where it's square root of 2 over 2. So sine of pi over 4 is root 2 over 2. Cosine of pi over 4 is root 2 over 2 minus parentheses. Sine and cosine are not both 0 at 0, so we don't just cancel these out. Sine is 0, but cosine is 1, plus 5 pi over 4 is in the third quadrant, and sine and cosine are both negative in the third quadrant. So a negative times a negative gives us a positive root 2 over 2. Same thing for that sine value. Minus parenthesis. We looked at cosine of pi over 4 was root 2 over 2, but this one's being multiplied by a negative. And same thing for our sine. These, I'm going to distribute that minus sign. These all become positive. So we have 6 times root 2 over 2. The 6 over 2 divides to 3, so we have 3 root 2 minus 1, and again we were finding the area between the curves, so it's square units. Now we're going to take a look at example 2. and both of our equations are x equals equations. So there are two options on this. First of all, these equations are fairly simple to go ahead and solve for y and then integrate with respect to x. However, I do want to practice that integrating with respect to y again because that's a bit more challenging. And I only gave you half-true information on yesterday's lesson, so I apologize for that. So I want to do this in terms of y so I can fix that potential misconception. All right, we're going to take a look at these graphs. I have them typed in as we got them in the example with our x equals form. And as we take a look over here, from 0 to 1, the blue curve is the one further away from the y-axis, and the red curve is the one closer. When we look off to the left, the blue curve is still the one further away. However, this is where that misconception might occur. Looking at it as the curve further from the y-axis does work if your graphs are on the positive side of the y-axis. So what we really want to do is change that conception to the curve on the right minus the curve on the left, because then that will always work. So I do apologize for that. So if it's in terms of x, the curve on top minus the curve on the bottom. If it's in terms of y, the right curve minus the left curve. So now looking over here, this red curve is the one off to the right. So that's the one that we are going to start with for our integral. Subtracting the blue curve, the one on the left, and then it switches. The blue curve becomes the one on the right minus the red curve, the one on the left. Go ahead and pause the video again, get that graph down. Taking a look at our area, our first section here, the curve on the right is our y cubed curve. We're going from y is -1 to y is 0 of y cubed minus that curve on the left is the cube root of y, or y to the 1/3 power. Plus, looking at the section over here, the curve on the right is now our cube root. So y is going from 0 to 1 of y to the 1/3 minus y cubed. Now on this one, there is another option. Because those areas are identical, because our graphs are symmetric, we could do one of these integrals and multiply it by 2. So that's what I'm going to do as I evaluate. And since the second integral has just positive or non-negative bounds, I'm going to use that one. So 2 times, and I'm going to go ahead and integrate, adding 1 to 1/3, we get 4/3, and then multiplying by the reciprocal, minus adding 1 to the power, multiplying by the reciprocal, with bounds from 0 to 1. So we are going to double the area of this region. Subbing 1 in, I get 3/4 minus 1/4. Subbing 0 in, I get 0. 3/4 minus 1/4 is 1/2, times 2 is an area of 1 unit. Now you guys can check my work by integrating both or by using your calculator, but integrating each section and adding them does give us an area of 1 unit. This only works when those areas are identical because the graphs are symmetric. And our last example, we're going to take a look at an accumulation function. This is basically just a reminder that another way of thinking about an integral is as accumulation. So the further along the x-axis, in this case, that we go, the more area we accumulate under the curve. First thing we're being asked to do is integrate. So we have t squared. I'm going to go ahead and add 1 to the power. And then when I multiply by 3 in the denominator, I get 6 plus 2t. And we're going from 0 to x. So I'm going to sub x in for all of those t's. And when I sub 0 in, I get 0. So this is our accumulation function. Now what we're being asked to do is evaluate our accumulation function at different values. So subbing 3 in, 3 cubed gives me 27. 27 and 6 both have a common factor of 3, so I'm going to divide them each by 3 to get 9 halves. Plus 2 times 3 gives me 6. 9 halves is 4.5, plus 6 gives me 10.5. So that is the amount that has accumulated under the curve from 0, because that was our lower bound, to 3. F of 6, same thing, subbing 6 in for all of those x values. 6 cubed divided by 6 is really 6 squared, so we have 36 plus 12, which gives us a value of 48. And the last piece is we're being asked to sketch the graph of those accumulations. As a reminder, we are accumulating amount under the curve before we integrate. So I'm going to sketch a graph of this 1/2 t squared plus 2, which as a very rough sketch looks something like this. For a value of 3, the amount from 0 to 3 that we accumulated is 10.5. And at 6, the amount we accumulated starting at 0 was 48. As always, let me know what questions you have. Again, I noted on the assignment which ones I would like to see by hand and which ones you can do the shortcut calculator version for. Take care.